So thank you all for joining us. And my name is Severin. I run a farm in Pembroke, Maine, and I've been an organizer with young farmers for many years as the director of Greenhorns, which isn't really to do with mining at all. But because we live in Pembroke, Maine, where there is a proposed mine by Wolfden Resources, LLC, we've become involved in helping to organize in order to protect our clean water. And obviously this is an issue that a lot of rural communities are facing, is these extraction projects. And so as we've gone along, we've been connecting with many of our community members in the larger young farmer community who are also fighting these kinds of projects. So I'm so grateful that we have, although we've had for 40 years a moratorium in Maine against mining, and so we don't really have a very big anti-mining community in Maine. We do have a couple of great experts, and so we've been drawing on them. And one of them is Jan Morrill, who is the Tailings campaign manager at Earthworks, which is an organization in Rockland. And Jan's work focuses on mine waste, which is called tailings, and the social, environmental, and cultural disasters that result when mining companies put profits over safety. She works with communities around the world directly affected by dangerous tailings storage facilities, including in Brazil, the Dominican Republic, Peru, and beyond. Additionally, she seeks to elevate best practices in tailings storage on a local, regional, and international level. In June of 2020, Jan co-authored Safety First, Guidelines for Responsible Mine Tailings Management, a set of guidelines endorsed by 150 frontline community groups and civil society organizations from 24 countries that aims to protect communities, workers, and the environment from the risk posed by the thousands of tailing facilities around the globe. So Jan also worked for 5 years in El Salvador, supporting community-based organizations who were worried about the impacts of mining, and who eventually passed the government to ban metallic mining in the whole country of El Salvador, which is a first. And so we're really lucky to have her not too far away from us. And you can read more about her work and the wonderful reports done by her organization on the Pembroke Clean Water website, where we've been compiling a lot of learning resources. So thank you, Jan, for starting us off today.
Great, thank you, Severin, for that introduction. Nice to be here with you all. I'm glad we all have power today. I was a little nervous about that. I am going to share my screen. And
this is what you have to do.
And hopefully I'm going to be able to show you my PowerPoint presentation. All right. So forgive the technical problems here. All right. So like Severin said, my name is Jan Morrill and I work for Earthworks. Earthworks is a US-based organization. We're actually based in DC. And we have about 30 years working on issues related to mineral and energy development programs and the dangerous impacts that they can have on communities and ecosystems. We work hand in hand with affected communities to look for sustainable solutions. And like Severin mentioned, I'm the Tailings campaign manager, so I focus on mine waste, and we'll talk some more about that as we get going. So I thought I'd start off, this presentation is kind of be an overview, a little bit of a bird's eye view of some of the things we should be thinking about and looking out for. I think it's important to start by acknowledging that with this big silver project that Wolfden is proposing, there's a lot that we don't know. And there's a lot that we don't know because the mining company has not talked about how it plans to operate of its proposed mine in Pembroke. And I think it's helpful to put that a little bit into context, and pulling from the great white paper report that GEI did for Pembroke Clean Water. The reason that is where we are in the process of mining, right? So first, mining companies, they do data gathering, they reach out to investors to try and get financing, then they do initial exploration, Then they move into an advanced exploration stage. After that, they'll do their environmental baseline studies. Then they'll do their feasibility studies to see if they can make money off it. And then they'll come up with their designs. After they have all of the information, they'll go into the permitting phase where they'll draft an environmental impact study and start engaging more with the state of Maine's DEP. So right now we're in the initial exploration stage, which is why they're drilling holes, clearing lands, making roads, but they haven't had to present any sort of formal design for their project yet because they don't really know what they're going to do. So that makes it a little bit hard for us to know what's going to happen if they're able to start a mine. So what I wanted to talk about today are trends in the mining industry, especially in the United States. What's it look like in other places? What have we seen historically? So that we can have an idea of what we're going to be coming up against when they present their mining proposal. So examples, I want to start off by talking about examples of impacts of mining in the United States. I think it's important to know that the metal mining industry is the lead industrial polluter in the United States. And we know that because the Environmental Protection Agency every year does what they call the toxic release inventory, where companies are required to disclose the amount of pollutants they discharge into air, water, land, or transfer to other sites. And since the beginning of the TRI, which is almost 30 years ago now, over 30 years ago now, mining is always at the top of the list of the industry that is polluting the most air, water, and lands. So what does that pollution look like? One aspect of that pollution is something called acid mine drainage, and this is a form of water contamination. I think that Dr. Stephen Emmerman did a fantastic job of explaining acid mine drainage in the white paper that he wrote for Pembroke Clean Water, which is on their website, which you should all check out. So I wanted to kind of pull from his explanation to talk about acid mine drainage a little bit more. First of all, it's pervasive in the silver mining industry. So if we're looking at a silver mine, that's something that's very common, and it's really destructive. And what acid mine drainage is that when an ore body is ore bodies include things like sulfide minerals. And when they're underground, those sulfide minerals are stable because they're not exposed to air, they're not exposed to water. But mining involves digging them up from underground and bringing them up to the surface and exposing them to air and water. And so when those sulfide minerals that are in the ore body, where the silver and the gold and the yes, my cat's trying to jump up on my lap. I'm sorry about that. When they're exposed to air and water, there's an oxidation reaction that makes sulfuric acid. And so when those ore bodies start to produce sulfuric acid, it has a number of effects. It turns things acidic, which dissolves the other heavy metals that are in the ore body. And those heavy metals and other chemicals begin to leach as a result of the acidity. And so the dissolved heavy metals will flow downstream into surface water, groundwater, or anything that's below the mining operation. And it's really important to understand that there are no examples of hard rock mines on the planet today that can demonstrate that once acid mine drainage starts, there's a way to stop it on a large scale. Once large scale acid mine drainage starts going, there's nothing that can be done to stop it. You can mitigate it, you can do water treatment, you can look for solutions to make the best possible scenario out of a bad scenario, but there's no way to just stop it from happening, right? And I think the classic example that we see that people always talk about is that there's acid mine drainage in Europe from mining that happened during the Roman Empire, right? So it's something that happens forever in perpetuity and that cannot be stopped.
Roman.
In 2013, my organization Earthworks released a report that documented 40 hard rock mines in the United States that were generating 17 to 27 billion gallons of polluted acid mine drainage water. And that's every year. And those mines will generate that acid mine drainage in perpetuity. And so the treatment of that water is now oftentimes on the taxpayers, and we'll talk about that a little bit more. And one of those mines is in the picture on the left here. This is the Zortman-Landusky mine in Montana. This picture was taken less than a month ago by my colleague. And this is a mine site that was active decades ago. I've got a couple other pictures of acid mine drainage here just because I think it's very striking. The one on the left is another mine in the Western US. The one on the right is actually a picture I took in El Salvador. There's a really severe case of acid mine drainage in the eastern part of the country, and the color differences tend to be the difference in whatever the minerals or metals are in the water. So in El Salvador, they had a lot of iron in the water, so it looks rust, or in the ore body, so it looks rust colored. What's another effect on the environment, on communities of mining? What are more impacts? And another huge impact is mine waste. Like Severin mentioned, that's tailings. So tailings are the crushed ore and chemicals and water that is left over after the metals of value have been removed. So in the Wolfton's case, they're going to take out the gold, the silver, the lead, and the zinc, and then everything else is going to be left behind in the form of tailings. Normally, tailings are stored behind a dam that is built out of mine waste itself, either compacted or semi-compacted tailings or waste rock. And the problem with tailings is that and specifically tailings dams like this one on the left, this is actually in Brazil. It's not a US tailings dam, but there are many of the tailings dams in the US as well. The danger of tailings dams is that they can become very unstable if they're poorly constructed, if they become saturated with water, or if there's an earthquake. And when they become unstable, what happens is they go through a process called liquefaction. And liquefaction is when the soil-like tailings or the semi-solid tailings begin to flow and act like a liquid. And so the entire dam itself can collapse, and everything behind it begins to flow as if it were water instead of crushed rock and other materials. And this is oftentimes especially dangerous because since tailings are trash, they're what's left over that the mining company is not going to make any money off of. Companies try to minimize the amount of money they spend on their tailings storage facilities. And so they reduce costs as much as they can, which often leads to cutting corners for safety. So what can go wrong with tailings? This is a picture of a tailings dam failure in Brazil that was in the town of Brumadinho at a mine owned by the Brazilian mining giant Vale on January 25th, 2019. So just a little bit over 3 years ago. The tailings dam underwent liquefaction, collapsed, and released 9.7 million cubic meters of tailings downstream. This led to 272 deaths, mostly of mine workers who were below the tailings dam at the time of its collapse, but also of people living in downstream communities. And it's estimated to have impacted about 3 million people just because of the impacts it's had on water, housing structures. It contaminated one of the major rivers, which was used for fishing and livelihoods, destroyed crops. It was really horrific. So I'm going to try and actually switch screens here for just 1 second. And I want to show a video of this tailings dam collapse. It's really striking.
She's in Rockland.
Really?
So this is the moment that the tailings dam is undergoing liquefaction. And it looks like the side of a mountain collapsing.
Whoa.
Wow. And it was an earthquake, or what caused it?
It wasn't an earthquake, it had become saturated. The drainage systems in the tailings dam weren't functioning correctly, and it backlogged with water.
This is one of the things that we keep hearing from our mentors and advisors, is that the rainfall patterns in the Northeast are predicted to be even more unpredictable.
Climate change is very terrifying in terms of tailings dams because as more and more rainfall accumulates, tailings dams become more unstable if they don't have proper drainage, and it's you have to predict how much rainfall will be behind the dam. And as climate change changes weather patterns, engineers aren't accurately able to predict how much water is actually going to fall. So I want to talk a little bit about filter tailings, which are also called dry stack tailings, but we try to kind of keep away from that term because they're not dry and it gives a false impression. But filter tailings are tailings that have been compacted so that they have 25% of their original water content. So they're not dry, it's not like a dust, but it's more like a moist soil. And they're considered best available technology to date for tailing storage in the mining industry. And so it's important to know that in Pembroke, we're not going to have a traditional dam like the video I just showed, because Maine's regulations don't allow for the construction of conventional tailing storage. So fully or semi-saturated slurry tailings are not allowed in Maine. Maine's the only state in the entire country and one of the very few jurisdictions in the whole world that mandates the use of filter tailings. So that's good. We are not going to have wet tailings stored behind dams. We're going to have semi-compacted, drier tailings that are built into structures if we have mining in Maine, which we should, but it's also important to understand that filter tailings facilities still require what's called a structural zone, something to hold them in place, which is basically a tailings dam. And it's still made out of compacted tailings for its confinement. So that means they still need to adhere to stringent dam safety standards. A lot of times what we hear the mining industry say is that, oh, we're using filter tailings, so we don't need a tailings dam. Or, oh, we're using filter tailings, so there's no risk. But that's not true. And I want to show a second video actually, because there was a filter tailings dam that collapsed in Brazil last month, actually. What happened was the side of the stack of the filter tailings got saturated during really heavy rain in Brazil. There was extraordinarily heavy rain in the month of January, climate change again. And so the filter tailings became saturated and they collapsed. They collapsed into a dam that was downhill from them that was just containing water. It was a water retention and sediment dam that was on site, and it caused that water dam to overflow. So then the water dam overflowed and blocked a major highway in Brazil. They had to evacuate people downstream, and it's pretty striking when you see it. So I'm going to play this video now. So this is the side of the filter tailing stack. You can see where it just slid down, and you could see how the tailings then flowed downhill. And then we're going to see the edge of the water dam in just a second. And so then this here is where the water dam was. And so the tailings slid into it and caused this water retention dam to overflow.
Yeah, in our case, they'd already be in the bay by now.
Yeah. Mm-hmm. So, I mean, I think what's really important to remember when we talk about filter tailings facilities are safer and there are less catastrophic accidents than there are with traditional slurry tailings, but they still need to be built correctly. They still need to be regulated correctly, and they still pose risks. So this is kind of, you can see the damage that happened from the water and sediment overflowing. All right, so I'm going to go back to my presentation. Sorry, it's for the slow lag time.
It's wonderful.
Okay, so we've talked a little bit about what are some of the impacts that mining can have. I think it's important to understand that mining companies historically and currently do a terrible job at predicting what their impacts are going to be. And there was a really seminal piece of research that was published in 2006, which I believe is actually going to be updated soon, if I'm not mistaken, by Jim Kuipers and Ann Maist, that found that most mines that they studied, but most mines in general, have faulty water quality predictions. They have inaccurate or inappropriate mitigation measures that they think will solve their faulty water quality predictions, and that regulators give them permits based on bad predictions. And so they found 76% of the mines that they looked at that had said they would have no pollution, 76% of them were polluting rivers and groundwater with lead, mercury, arsenic, and cyanide, and that taxpayers oftentimes were the ones that were on the hook for remediation and cleanup. So it's not just that, you know, we think we don't trust corporations and therefore we don't believe mining companies when they say they won't pollute. It's that there has been historically over time studies that have shown that mining companies don't understand how much pollution they're going to make. They don't understand what they would need to do to stop it. And regulators don't understand when mining companies are presenting them inaccurate predictions. I think that's all really important to keep in mind. Just another example of how this plays out. Again, Stephen Emmerman's white paper that's on Pembroke Clean Water's website is great. He talks about the concept of prove it first legislation. And he states that there's no such silver mine that has not created acid mine drainage and pollution. And the reason that he states that is because there's a law that was passed in 1997 in Wisconsin called the Prove It First Law. Emily Carpenter from this great state of Wisconsin is on this webinar today, and I'm sure she could tell us more about it if she wants to. But this law basically said that any sulfide ore mine to get a permit to operate in Wisconsin had to show an example of a mine that had operated in the United States or Canada for 10 years and had been closed for 10 years and didn't show any signs of pollution for the surface or groundwater. While that law was in effect in Wisconsin, no mining company could give an example of a mine that didn't pollute. And so therefore, no mining company received any permits for mining in Wisconsin. It was essentially a de facto ban because no company could prove that there was a mine that doesn't pollute. There were companies that tried, and they presented about, I think it's 5 different examples of mines where they claimed there was no ground or surface water contamination. But when the regulatory bodies looked at those applications, they found that there actually was pollution, and all of those permits were denied. There's a proposal to pass a similar law right now in Minnesota, another Prove It First law. And I think what's important to understand is that as mining companies are again saying, like, we can prove that we're not going to pollute, they're still using those same five mines from the early 2000s as their examples that there's non-polluting mines. So there's no new mine in the meantime that's started operating for 10 years and closed for 10 years that can prove that there is no contamination. And so what happens with all of these environmental impacts? Oftentimes companies leave. They leave their mines behind with the pollution. And that happens a number of different ways. Sometimes the company goes bankrupt and just cuts and runs. Sometimes they sell the mine to a subsidiary that doesn't have enough money to pay for remediation or cleanup. And so the US government estimates that there's as many as 400,000 abandoned mines in the United States on public land, only on public land, so that's not private lands. And the EPA says they don't know how much it will cost to clean all of those mines up. Some of the estimates are around $35 billion. And federal agencies say that they usually spend 80 to 85 million a year on, or that right now they're spending 80 to 85 million a year on abandoned mine remediation. So mining companies do not take responsibility for the problems that they create when their mine is over, or when it's closed. So I think that's just something else to take into account. And I think on probably the last webinar that Friends of or Pembroke Clean Water organized, I'm sure Ralph Chapman talked about the Callaghan Mine and the mines in Blue Hill, but that's what we see there, where they're super funds and the mining company doesn't exist anymore. And so taxpayers are holding the bill.
And he reminded us that that was $500,000 a year in the case of the Callaghan Mine in Blue Hill, Maine, and that the clam flats are still and will permanently be closed and contaminated, so that it's mitigation, but it didn't solve the contamination.
And so then the last thing I just want to share is that, you know, Wolfden's a Canadian company, and the Canadian mining industry is notoriously bad, right? Like very, very bad. The Canadian mining industry is one of the largest mining industries in the world. Canada and Australia are the top two. The government of Canada actively promotes mining both nationally and abroad, but with tax incentives, with lobbying, with access to regulatory frameworks and changing laws. But there's significant documentation of environmental and human rights abuses of Canadian companies all over the world, both in Canada and abroad. I just put a link, and I can share this PowerPoint to a report from 2016 that was done by the Committee for Human Rights in Latin America, which is a Canadian-based organization, where they looked at a number of different environmental and human rights abuses by Canadian companies abroad. This picture is from the Porgera mine in Papua New Guinea. It's a Barrick gold mine, and there's been really horrible environmental and human rights abuses at that site. So while mining companies don't do a great job of not polluting, they don't do a great job of predicting what their impacts are going to be, and they have a really bad reputation around the world. So with that, I will finish up. There's my email. Anyone should feel free to email me anytime. And I believe we're going to take some time at the end after all three presentations for question and answer. So I'm happy to answer any questions when we get to
share your screen.
Thank you so much, Jan, for sharing and giving us that context.
Your screen, yeah. Wait.
We were so grateful to be approached by Andrew Stanchoff, who heard about the mine thanks to the wonderful Lise, who forwarded on the information. And it's interesting how the kind of grapevine has been helping us find these mentors to learn from. Mr. Stanchoff is a geologist and a natural resource planner with 35 years of experience in geology, hydrology, forestry, climatology, oceanography, especially in developing countries, and 24 years in Africa. Mr. Stanchoff has worked to develop methods and models to monitor and evaluate poverty and conflict in areas under stress from overpopulation and overuse of natural resources, has been involved in modeling demographic, health, and environmental data, especially in support of early warning systems for famine. In the 70s and 80s and 90s, using satellite imagery, he mapped some of the geologic, hydrologic, and natural resources of Zaire, Guinea, Central Africa, and Mauritania, and developed some of the first environmental degradation maps and for resource potential in Senegal, used by the World Bank and the USGS to develop the National Geographic Information System. Since retiring, he has been involved with the Camden Conference, and that's another place you can watch a lecture that he has given. So thank you so much, Mr. Stanchoff, for making yourself available to teach us more of what we need to know about the particular geology in Pembroke, in the uplands of Cobscook Bay. Are you ready for us?
I'm gonna try.
That green button on the center of the bottom is where you share screen.
Share the screen.
Yeah, I've already done that.
Okay, now then you hit that PowerPoint. PowerPoint, this one. There. Should come up. Okay. Here it comes.
Brilliant teamwork.
Okay, now I've got to go back. I don't know why I've got that one.
Start video.
Where is it?
I think if you go to slideshow, that drop down, it'll say start from beginning, I bet.
Slideshow. There's a slideshow. Hit that one.
Yep.
There you go.
And then play from start, the far left.
Play from start. Lower left. There we go. There we go.
Hey,
Brilliant.
Woo!
Woo! Now your blood's flowing.
Okay. Can you see the slide?
Yes.
Okay. So basically, first of all, I want to thank Jan for giving a really good introduction to what I hope I'm going to be able to add a few glimpses of information to. And then thank you, Severine, for inviting me. And I wish Lise McLaughlin were listening. She is a real sort of a guardian angel.
We are listening, Andrew.
Go for it, Andrew.
Good for you. And anyway, I think you're the guardian angel of the environment in our area. So here we go. So I'm just going to talk about some aspects of geology and the landforms and other characteristics in the Pembroke and Cobscook area. And because I think that very few people really understand the significance of what the earth really is telling us that we should or shouldn't do. So I'm going to move on to the next slide.
You can see what you're doing.
Whoops. Whoops, that's not the next slide. Something's happened here.
That's the end. You gotta start.
I'm going backwards. All right, start all over. Sorry about that.
Play from start, lower left, left, there.
I think if you
Okay.
just click on the screen, it'll go to the next slide.
Well, it did, it was meant to, but it didn't. There it is. So first of all, I just want to talk a little bit about the area. And most of you know that there are 9 communities, and I think all of them will be affected if the mine goes in. And one of the most important aspects is, I know Severine has a farm and there are a number of other farmers, but most of the people who live in the area, if I'm not mistaken, live off fishing and fish farming and other jobs. I tried to find some numbers, and that's the only one I really could find for 2021. About $20 million worth of seafood was collected, harvested in the area of the Cobscook Bay over the last year. Another aspect of the economy is that 90% of Maine's blueberries come from Washington County. And by the way, if I make any mistakes here, cut me off, stop me, and correct me. And I think that any air pollution that would come from a mine, from the crushing and so on, would and could have an effect on pollination and the harvesting of the bounteous blueberry crops. One of the things I found really exciting is that I found out that on Lake Medibemps, which is just north of Pembroke, there's a red paint culture site. And the red paint culture existed about 6000 BC. And this site is on the list of National Historic Places. So I think it's kind of an important, it's an important fact that I wasn't aware of before. So these are not so pleasant facts. And whoops, sorry, back. Oh, there we go again. All right. Okay, now these I can't see my whole slide because nice pictures of nice people are blotting some of it out. But
I can see the whole thing. We can see the whole thing.
I will turn to my notes. So anyway, this prehistoric site that I was just talking about is on the outlet of the lake, or very close to it. And that outlet leads to a stream, which is, I think, called the Dennis River. And it goes all the way to Dennisville and empties into the bay there. Very near to that site is the Eastern Surplus Company dump, which is another EPA Superfund site. And it was used from the 40s to the 80s for dumping of all kinds of stuff. It's a 3-acre site and is surplus military equipment, salvage items, transformers, drums, gas cylinders, and other containers there. And there's a lot of stained soil or toxically affected soil. Both of these are very popular sites, that is the river and the lake, for boaters and anglers. But even though the EPA and the state have been trying to clean it up, and over 30 million has been spent, there's still a lot of problems and it's not clean. I have to remind you that Dennis River is Atlantic salmon stream and an alewife habitat. And Randy's handing me a message. What is it?
Just take your hand off the mouse. You're jiggling around so much.
And this area is also a very important area for alewife habitat. And the bay is a major producer of scallops. I don't know if any of you know, but up Route 214 is the Ohio Brook disposal site on Ayers Road. And who knows what's buried in there. I have no idea what the dump has been used for and for how long. I suggest that somebody look into that. Okay, I asked the question, is this what you want? This is the tailings facility of the Brunswick number 12 mine in New Brunswick. There are 42 mines in New Brunswick. As Jan was saying, Canada is rather ahead of most countries in the mining sector, and possibly in not a very positive way. This mine began operating in '64, and it was the largest underground zinc mine in the world. The tailings pile and waste covers 1.3 square miles. And let us underline the fact that a water treatment plant must operate in perpetuity at this site. You'll find the water treatment plant up in the eastern side. That has to operate in perpetuity. And consider that the entire area, including the quarry and the tailings and the buffer pond, are 1.25 miles long. And it's only about 2 miles from Pembroke to the proposed mine that Wolfton is hoping to exploit. All right, now we're going to turn to some geology. And there's a lot of stuff that we can talk about here, but I think I'll just keep it simple. I have a big light green circle, which indicates the area of interest to Wolfton. This is a geologic mine of the area. Pembroke is down here where my pointer is. This is the Pennamaquan River. The lake is just up here. The dark green circle surrounds the area where the you might remember a photograph that Jan showed of the Wolfton a pit. And that pit is right in this area, and in this formation. This formation is designated as SLB, and that is a Silurian rock formation, which is 400 million years old, which has no import to the mining, but and then there are three other areas that I've circled there in black, and those two have potential for having a what we call ore deposits or volcanogenic ores like lead, zinc, silver. And these sites could be just the beginning, because there are many other possibilities in this sector for the kinds of mines that operate in New Brunswick. I suspect that there's much more ore in this sector than we think exists there now. And
One thing to add is that the Wolfden associates have now been working in the towns of Charlotte and Dennisville, which would suggest that they are following the ore as you are saying.
yeah, I can go back and I will show you. Dennisville is down here, just below my pointer. And all these rocks that are sort of darkish blue, they all have potential. They're all, you all saw the other day that we had a huge explosion of a volcano in Tonga. It's these undersea volcanoes that are in the right place for the, let's say, the creation of ore deposits of the kind that Wolfden is looking for. You have hot material coming through other rocks, dissolving the potential lead, zinc, silver, gold, whatever it might be, and aggregating it through a process of melting and using the seawater as a way of bringing it together. I'm simplifying it, but that's the process. And most of the world's richest deposits, what we call volcanogenic, volcanosedimentary deposits, are found in these kinds of rocks. So the yellow and the orange rocks here, Devonian, and they're not of great interest. They're mostly sedimentary. This is something I got from one of Severine's initial things she sent out. And this is the Wolfden lease area. And what you can see on this map are a lot of blue lines, which represent the ownership by individuals of these pieces of land. You see some of the drainage. I just wanted to give you a sense of the size of this exploration request. This is something that appeared in one of Wolfden's public relations flyers, and it shows things that you've probably never seen. I'm not sure of what the white circles with the black dots are, but I suspect they are the sites of previous drill holes. I've heard that there are drill cores in a house somewhere in Pembroke. Maybe Severine can tell us a little bit about that. Severine, do you know about the cores that are located in Pembroke?
I sure do. I mean, well, I know that the previous mining companies there, which were Denton Mines and then Sinalor LLC and then Golden Hope LLC. They all, two of them had their offices in the building that I bought from the town for back taxes. And behind that building are 4 sheds, and the sheds are full of racks, and the racks are full of mining cores that are about 4 feet long and about 3 inches diameter. Rock that was drilled to
Yeah.
map out the ore body. And those cores also were stored in the basement of the building, and they were actually underwater for quite a long time. When I got to the building, there was about 5 feet of water standing in the basement, because it's a very, very wet place. But there were some of those cores that disappeared, and the mining company really wanted access to those cores, and they came around trying to get them, and they sent people to our house. And anyway, the more they wanted them, the more I realized that we didn't want to hand them over. And I wish I could know what exactly those cores say to have some kind of a fact check on what the company is claiming.
Okay, so I think what I'm doing is trying to connect the two. I believe that the cores you have may represent some of the drill hole data that came from these locations here. Now, let me talk about the map to explain to you why they drilled those holes where they did. You'll notice 3 groups of colors. There are reds and pinks and yellows, and then there are blues and there are greens. The reds, pinks, and yellows are rocks that have been measured by flying over them with a magnetometer that indicate that they have large magnetic response, that they have a lot of magneticism, if you want, in them. The blue have almost nothing. The green are sort of in between. Now, they've drilled and are interested. This is where the Big Hill area is, north of Pembroke. That's the Big Hill area right there. And Pembroke would be down here. Now, these pink areas are interesting because they are high magnetic anomalies in the middle of low magnetic response. So when you find, if you go around on the beach with a metal detector, you've got sand and it doesn't respond at all. But if somebody dropped a quarter, it will give you a magnetic response. And so that is what they've done, is they've measured the magnetic response of the rocks in this area, and they found some very good responses. There may be more down here toward the Dennisville area. And so I just introduced this so that you understand. Now, how is this done? They have an airplane, they hook up a magnetometer behind it, they fly over a region back and forth, and until they can produce a map, like a topographic map. And that will provide them with this kind of information, so that these lines, these black lines, show lines of equal magnetism in the subsurface. I hope you understand that. If not, you're going to ask me later.
You're saying this underscores the reason why Wolfden is acquiring more land, which we observe that there's more acquisition going on actively in the Registry of Deeds, and that there's a tremendous amount of logging going on all sides of the core exploration area.
I would say you're right, but I would say that there are other techniques that have been used that I have no access to. And they're called IP or induced polarization. And that's another thing that you haul behind you, and it measures the polarization of the rocks. It's kind of the reverse of the magnetism, but it tells you what the potential for metallic rocks or ores is underground. This is a, can you see the title on this?
Yeah,
LiDAR?
Yes.
Okay, this is a LiDAR image, and it shows the exploration trenches made by Wolfton and maybe others. This is Big Hill, and here's one exploration trench, here's another one, here are two little ones. Now, why is this so different from what we see on an aerial photograph or what we see in satellite imagery? The LiDAR is a kind of a more powerful radar, and LiDAR is light detection and ranging, and it uses laser beams. And what it does is it penetrates the forest. So you won't have any forest here at all. And what you see is what is underneath. And that's very important, because if you're a mining company, you don't want to be rooting around in a place where there's a huge amount of overburden or rock and soil. You want to find as many rock outcrops as you can. So for instance, as I drag my pointer across, you'll see there's a little ridge there. Well, that's probably all rocky. These other ridges here also indicate rock. This is all rocky here. This was obviously a rocky bluff where there was an outcrop, and they dug there. These are rocky places. They may be covered with a lot of forest and some soil. You'll see that there's a smoothness in this part here and in here. That's probably just a lot of soil brought in by the glaciers. And so they don't want to dig there unless there's evidence from other techniques that says, yeah, let's drill through all that overburden. Let's drill through all those rocks and gravel and stuff and get down to the hard rock. Now, another thing we can do with this image is we can do some geologic mapping. So that, for instance, this straight line that I'm going to be following, this kind of arcuate line that I'm following, is indicative of a fault. Now, if you recall, an earlier picture showed a big blue area, which was a low magnetic area. That's this one right here. So that's why you don't drill in there, because the fault separates the low magnetic stuff from the high magnetic stuff. So all these techniques provide the mining companies with information that you'll never know about, because you just see a plane flying up there, you have no idea what it's doing. But I can tell you one thing is the Maine Geological Survey, which did this LiDAR flying with money from the federal government. They repeated the flight lines. I mean, I've seen the flight lines, and they repeated the flight lines over this area that Wolfton is interested in. So they flew it twice, and they wouldn't have done that unless somebody had asked them to. So there's some hanky-panky going on there as far as I'm concerned. So let me see if there's something else that I can show you. Oh yeah, if you'll notice under the R of laser, there's a straight line coming down like that. That's a road. And you'll see that road, it comes off 214, which is right across the top there. So this road goes down right to that pit. All right, so now we'll move on. This is another LiDAR picture, slightly different aspect. This is Pembroke. This is the water body, the bay. This is that fault that I told you about. That's Big Hill. This is the area where the pit is, and this is where they wanted to mine. These lines that I've accentuated are lines where one can actually see the outcrops under the forest cover. One of the most fascinating parts of this is that you'll see a kind of a washboard effect just below the town of Pembroke. That is the evidence of the glacier's recessional steps. As the glacier melted and withdrew across northern Maine, it would stop periodically, and it would then leave rocks and debris behind, and then it would again begin to melt. And each one of these is a little terrace that shows where the glacier retreated. There are more of them up here. This very smooth area here is probably the trace of the glacier that brought all that down. It never managed to take down the big hill any more than the glaciers here in Camden and Rockport were able to take down the Camden Hills. Why? Because the rocks are much harder, and so the glaciers had a difficult time doing that. So the rocks in the excuse me, the rocks in the Big Hill, Wolfton area are hard, and they are the ones that maintain these the heights of these hills and keep erosion from the glacial erosion from having taken them down. What you'll also notice here is that this area is of the pit and a Big Hill is an area which drains in two directions, and we'll get to that in a second. It drains north and it drains south.
Just click on the screen.
I'm trying to click, there it is. Okay, this is another question I ask. Is this what you want or need? Now, this is supposed to be talking about Jan's presentation. This is supposed to be one of those wonderful minds that is perfect, but unfortunately it's not, and it will never be. From my perspective, even though it's shows very well in the legend what's going on and what they're doing, the water management is a big problem. You need an enormous amount of water to keep this this kind of mine from causing a problem. So I'm just going to move on from it, but it's an example of this is called the Eagle Mine. It's in Michigan. All right. Now, this is a satellite image from April 2021. Severine said that there was a lot of water in that shed, and I don't know what 2021 is like for all of you who live up there, but apparently it was a lot more water than usual, because I have emphasized the wetlands between Pembroke and West Pembroke to show the problem that you're going to have if you develop the mine up here. You got a tremendous amount of drainage that focuses on Pembroke. And now some of it would, this is Route 214. I just want to get you oriented. Here's another map. I'm sure some of you have seen it. These are the wells in the Pennamaquan and Pembroke, West Pembroke area. There are 94 wells in the area, and this is where the pit, the two pits are. there's actually another pit way out here that I only found a couple of days ago. And there's a lot of heavy, very heavy equipment, and it's not lumber equipment. There are also a couple of brand new houses or places where they probably kept their crew working, taking care of their crew, and they're right about in there. Now, these wells, as you can see, are all in this drainage area, and I'll show you how bad that can be. But you can see that if you have drainage from the mine going north along this creek and the Ohio Creek, it'll go in Pembroke Lake, and then to empty it has to go down Pembroke River and affects all these houses and the wells along the way. And on the other hand, if you look at the area of Lake, well, the other lake, Bemps, Pemps or whatever it's called, and the Dennis River, you have a whole other effluent that could bring toxic material down from there. This slide simply shows what I think would probably be the extent of the mine area with all of the, parking and haulage and tailings and rock storage. And it's 2 miles by 2 miles, and you can see how close it is to Pembroke, and it covers West Pembroke. The blue emphasis is on the streams that I think are important. This is the Dennis River here that comes down like that. Okay, this is the one that really emphasizes the problem of drainage. You can see the mine would be right there. It covers a very large area. You can see the drainage. Either, if they have the slurry and all that on the north side, well, then it'll just dump into the lake up there. I'm sure they're going to try and do that, but you have to realize that it would just flow right down into the bay here. So there's no way they can keep this thing clean. These yellow objects are big sand and gravel areas that the glaciers left. The little black spots are outcrops that people have found. That means rock, where the rock is visible at the surface. Of course, it's visible at the surface along the beach too, but I just wanted to point out there are not a lot of outcrops. Everybody's probably seen this, but Severine has sent it out. But I just wanted to point out that if this were the Pembroke River, this were the sand piles I just showed you, and this is glacial till or glacial outwash or glacial soil. And this is Big Hill, and that's where they're going to mine. You can see what the danger would be. This is a perfect example of the problem you have right there. And I don't know who designed this, but it's very well done. Okay, now I'm going to focus on fishing and hauling. There's an area between Cutler and Grand Manan, which are outside in the Gulf of Maine, but where biologists from the state of Maine and have used underwater cameras, robots, and so on, and they found the huge concentrations of fecund female lobsters, and those are the big producers. They're 3 to 5 pound lobster females that lay as many as 90,000 eggs, whereas the typical 1, 2, or 3 pounder, the less than 3 pounds, will lay only 2,000 to 5,000 eggs. So the bigger they are, the more they produce. So you don't want that whole area of Cobscoat Bay and the area between Grand Manan and Cutlet to be polluted. Scallops, the area of within Cobscoat Bay is well known for its incredible scallops. Sea urchins, or horse eggs, as they're called locally, are also fished in this area. And aquaculture is increasing, and that would be destroyed if any. So I think you have to go to the people who do the agriculture and get them on your side. So this is the area of Cobscoat Bay, and I'm just quoting. It's one of the best sea scallop fishing areas in Maine, and this is all in here, especially in the area of Dennisville and Pembroke. This is a map of the 9 aquaculture sites that have been approved by the state. The green ones are approved, and there are a couple of little bitty green ones. One is there, and another one is up in here somewhere.
That little bitty green one is my oyster and seaweed farm.
Okay, sorry, didn't have your name on it.
It's okay.
All right, and that's yours?
Yeah. In Schooner Cove, but the rest of them are cook aquaculture. So those are fish pens, salmon pens.
Yeah, but still, I mean, they're endangered. And I don't know what this M12 is, but they're asking for a permit.
Who is M12? Where's M12?
I don't know,
All
it's
right.
right. So, but I certainly would get them on your side. And there's another one, and I can't, whoops. Let me see if I can dig it out. Okay, oh yeah, there's one up here across from, I guess it's Eastport, in there, right in there. So all these people are going to be affected. And the next one is, okay, here are the problems. Contaminated wells. Because there are farms there, and I'm assuming there's some cattle or other animals.
There's a new guy who just bought the farm, the dairy farm that's directly to the south of the proposed mine site. He's a young farmer from California who wants to move there and start a dairy.
There you go.
Good luck.
So you have contaminated streams and lakes affecting fish and other fauna, especially the salmon that still go up and down. The bays will be affecting lobstering and scalloping. Transportation will be held because you're going to have these huge trucks breaking up the pavement and causing problems. If they haul the stuff out of here, out of Maine to take it to New Brunswick, that means the roads to between the mine and New Brunswick will be in terrible shape. I believe air pollution is going to be a problem because they'll be crushing ore, and wind transport is most frequently from west, southwest, and northwest, even though for the last 2 days we've had an Oyster, but that's not the usual. And the stripping of forests will create erosion and destroy wildlife habitats. And as Jan said, remediation always falls on the taxpayer, and it's the locals that suffer. Jan also mentioned the unexpected increased precipitation that climate change will bring, and could bring increased toxic runoff. And if mine people plan the way they used to plan on the basis of the numbers, of rainfall numbers of 20, 30, 40 years ago, they're going to have a real mess, or you're going to have a real mess on your hands, because the dams will not hold the tailings. And so, as I say, if you don't have enough information, ask the people who live at the Callaghan Superfund site, and this is it. Unfortunately, this point, the east side really points north, but this is a complete toxic, accident that just keeps giving. And it's going to take years and years before they can get that cleaned up. You do not want that. So that's it. Thank you very much.
And thank you very much. You've given us a lot to process. And I hope you'll stay on so that we can thank you more and bring questions to the floor.
Good.
I want to move speedily on to more about the health impacts, thanks to Bruce Taylor, who I met because he called, because he read an article that we wrote in the Ellsworth American. So I want to just thank everyone who is attentive to these issues and who works in advance of the poison. It's a different set of people than I'm used to working with, and I'm really amazed by such wonderful people as Bruce. So Mr. Bruce Taylor is a physician concerned about environmental effects on health. Throughout his career, both in civilian and military practice, this has been a major focus. Mining is a vital industry, but it has detrimental effects. The process of bringing metals locked under the ground to the surface and processing them releases toxic metals such as lead, arsenic, and mercury. Fine particulate matter generated by mining and the metal processing is a major health threat. These toxics can contaminate our air, water, and soil, and as they enter our bodies. Bruce Taylor is a board certified in pediatrics and anesthesiology and is a fellow of the American Academy of Pediatrics. And he's spent a lot of time in his career with a special interest in the significance of environmental contaminants on health. Thank you, Bruce. He's coming to us from Sweden, Maine.
Great, can you hear me?
We hear you, and Jan's got your slides.
Okay, well, I'm gonna try screen share first. So thanks a lot for having me. I appreciate being with such astute and learned people. And, as a physician, I use lots of metals and lots of plastic. And let's see. Okay. Can you see that?
We see it.
Dynamite, and as a physician, I use lots of metals, in my practice, and lots of plastic, because we're not talking about plastic. So on one hand, my professionally, I'm dependent upon it. And on the other hand, as a physician, when somebody would come before me and say, and we find out they have a tumor, and we talk about therapy, and we look at what we're going to do for the tumor with drugs. You might have a drug that could kill the tumor or reduce it, but then you have to talk about the side effects, you have to talk about contraindications and drug interactions. You have to consider that, and that's called informed consent. I sort of apply that to mining because this has great, health effects. And again, mining is very, very important. And we've been talking about water, to an extent, air, sort of the geological cycles and the cycles of production. But right in the middle of that, are going to be people. And that's very important. And as you can see here, it's been talked about before, this is the EPA toxic. I have to emphasize toxic release inventory done every year. And if you look at all the industries in the United States, metallic mining produces 44%, almost half of those toxic releases into the environment for which we live. In fact, it produces as much toxic releases into our environment as the next 6 industries do that. And if you look at what they do with the data toxic releases and what do they do with it? Well, some companies can say, for example, if they have sawdust, they can turn they can turn it into energy. If it's metal cans, they can recycle it. But this right here shows that there's no recycling, no treatment, no recovery. It's basically a release. When they talk about a release, they're basically talking about it, leaving it into the environment or dumping it into the environment. And again, if you look at this chart here, it just shows compared to all the other industries, metallic mining by far has to dispose of it, and they dispose of it on top of the land or any way they can get rid of it. And again, if you look at this in this slide here, if you look in the far right corner, all I want to show, they have a program called source reduction, where you reduce the source, you reduce the amount of toxic you're producing. And if you look at this with mining, you can see source reduction 0.0000 of 83 mines. Dude, this year, no source reduction. They couldn't reduce their toxins. So when they say, oh, we're advancing everything, we have new techniques, show us, because right here, they ain't reducing a darn thing. And this is a list of the kind of metals you're going to be dealing with right here. And it's important. I sort of look at these metals here, and HAPs are hazardous air products. And if you start looking at the big ones, arsenic, mercury, and lead are the big ones, and also chromium. Chromium, the valence of 6 was what got Erin Brockovich her fame or infamy, however you want to look at it, in Hinckley, California. But if you look at all these are metals of potential health concern. And if you look under 33 urban HAPs or hazardous air products, 8 of those are commonly from metallic mining, and they're the most common. So again, what we're dealing with are a lot of toxic metals that have health concerns. And again, if you look at of all the arsenic that is entered into the toxic release inventory, 95% of that comes from mining itself, 91.9% of lead. And look at cyanide, they're using almost a third of all the cyanide used, and cyanide is used by the pharmaceutical industry as an intermediate. This is something they use in N. Again, you're looking at the baddies here: arsenic, lead, mercury, antimony, cadmium. And although cyanide is not a metal, it shows you that they're using some real concerning chemicals. And mining will say, oh, don't worry about it. We have, we're going to take care of it. But at least the medical literature here shows that toxic metals represent the ultimate form of persistent environmental pollutants because they are chemically and biologically indestructible. There's an exception: uranium, thorium, radioactive things that have nuclear decay, but at least the medical field recognizes that once you bring them up to the surface, you can bury them, maybe you can put them in tailings. You can dump them in an old quarry that nobody wants, but they are still toxic. And they're going to be toxic forever, not 100 years for the life of the mine, or not 100 years for the life of the tailings repository. That may be different, because as you know from Mount Pickett, those of you that have been following Pickett Mountain, what did the lawyer for Wolfton say with their proposed plan at Pickett Mountain before they had to withdraw before Wolfton had to withdraw their proposal, because it was going to get voted down because it was so terrible? But what she said is, because the Land Use Policy Commission was concerned about all the toxic tailings, they said, oh, well, we won't leave them there. We'll move them to another town like Holton. And if you listen at 26 minutes and 30 seconds, I think the lawyer for Wolfton said, or maybe we can move them to Pembroke. So isn't that nice? They're going to be moving their toxic tailings around to try to avoid the law. And where do they want to put them? In Pembroke, maybe. But listen to don't take my word for it. Listen to the recording and talk about the Callaghan Mine. This is the Callaghan Mine. Now, granted, the new mining law restricts the size. It says no, the people say there's no open pit mines, which is not correct. If you read the fine print in the mining law, you can have an open pit mine of up to 3 acres. This is a Callaghan Mine, and looking at the radius they gave, it's about 18 acres. So this is large, but this kind of thing you're looking at. And when it was shut down, it was mined back in the 1880s. Then sort of wasn't used. And then from 1969 to 1972, it was mined. Then the Callaghan Mine Corporation went bankrupt, so they left it as a Superfund site to be remediated, which is said before, the main taxpayers through the Department of Transportation budget line pay 10% for every year that they've been remediating it. It was closed down in 1972. So approximately, what would that make it? 49 years ago or so that they still haven't cleaned up the Callaghan Mine. Although again, they say we have the technological ability to clean everything up. How come it hasn't been used in the Callaghan Mine? And again, both Senator Collins and Senator King said that just recently, back last December 17th, it poses a threat to the health of the residents of Hancock County and the Penobscot Bay. And that's been since 1972, or even earlier than that, because they found out there were PCBs or dioxins in there. Nobody knew how they got there. And again, talking about the effect on environmental health, that the shellfish, if you look at this map here, that you can't harvest shellfish around the Callaghan Mine. And this is closed down by the Bureau of Marine Fisheries. Now, they have closed down areas due to sewage, and they've closed down areas due to algae. But this is the first shellfish area that has been closed down for years due to metallic mining. And those metals are there forever once they leak out. And if you look at this right here, they did a study. And as you can see, that having a mine in your area is going to affect your land, your tax revenues, your land values, and most important to me, it's going to affect your children's neurodevelopment, that of the small child and that of developing fetus. In fact, they did modeling because nobody lives in this area, but they did modeling. What if people live there? Well, you would have at the locations I looked at around the mine, even back, and I think this was in 2002, the study was done. So even in 2002, at 3 out of the 4 locations doing a model, because nobody lived there, there's an elevated probability of exceeding the 10 microgram per deciliter threshold. And since the Center for Disease Control lowered it down to 3.5 on the acceptable levels of lead in the body, because the more we learn about lead, the more toxic it is. But even back then, they recommended that no children, or if you look on the bottom of this, for children under 7 years of age or pregnant women, they would have been exposed to very toxic levels. And that's when they only thought that 10 micrograms per liter, a deciliter of lead in the blood was bad. Now, as we've studied more and more and more, it's even less than that. And if you look at this side here, and if you look at the bottom yellow area, the bivalves there in Goose Pond right by there have levels of lead of 7.1 micrograms per liter. So you start eating that stuff consistently and you have a problem. And why do I get upset? Because if you look from the Australian literature, and it's been said, the people who really have the mining experience are the Canadians and the Australians. Children exposed to toxic mining do worse at school. They were more than twice likely to have developmental disorders than national average and perform lower than neighboring peers on school tests. In fact, when you look at some of the areas that have been classic for mining, Broken Hill, and you compare it to other areas that with exposure to dust and soils, consistently they had the lowest literacy score. And and they found that also similar to other areas such as in Mount Isa and Port Pirie. So again, if you look at children's development, children's education, being around mines, especially with lead, but there are other things, arsenic, mercury, and even zinc. We need zinc in our body. You can have zinc deficiency, you can have zinc overload. It's a fine balance. When you get too much, you can run into problems, and that's what they found. And this is what really gives me heartburn today in Maine. I got this out of Google Maps. I wasn't sure, but this is where I thought, you can see here, this is where I thought about where they might be mining in Pembroke. And you can see the line, and it's 1.34 miles or 2.16. From Pembroke Elementary. That is profoundly concerning to me. When you look at dust, when you look at particulate matter, when you look at exposure, that is profoundly concerning to me. Are they going to mine there? I don't know. How are they going to mine it? I don't know. But I tell you, that is a real red flag. Go ahead and measure yourself to see where you think they're going to have the open excavations. And again, not only open excavations, but machinery, rock crushing, and then where they're going to have their tailings. Because remember, tailings are going to be affected by wind, and it's been shown everywhere that when you have a 20, 30, 60-foot tailings pile, even though they cover it, there's going to be a release of the toxic metals that they've concentrated by tailings, has been stated before. So this gives me real heartburn right here. And the other thing that I didn't really map, if you go down the other direction towards the water, again, it's going to be near with just from by distance to the water. And then we talked about not only the air contamination, but the water contamination flowing everywhere. So this is a real problem. And all I can say is that's a major red flag. I won't use any four-letter words, but I think that's a major red flag right there. And what do they do? How is mining pollution dispersed? Well, we talked about it, the watershed, but also the air shed. The air shed up in the air when they crush the rock, or when they do beneficiation or smelting. And under the law, LD 820 in the Chapter 200 mining rules, they can go ahead and do smelting in the mining area, or they can, wherever they do smelting is a mining area. So go in the air, they can have watershed, and then soil, the kids playing. And then, as was mentioned before, transport's a big deal. Like the lawyer for Picket Mountain said for Wolfton, well, maybe we'll, truck in some of the tailings into Pembroke. Well, just along the way, they're not going to hermetically seal trucks. It's going to be, all the dust is going to be going everywhere. And when they transport mining materials and mining waste, if they take it up to New Brunswick, you're going to have a trail. You're going to have a trail of pollution. And why am I concerned? Well, this is a study done by University of Arizona. If you look in the upper right-hand corner, you can see mining operations and active mine tailings. And what they looked at are three major factors: potential particulate emissions, potential contaminant, and then the risk to human health. And voila, on all three categories, there is mining. Down on the other side is forest, which they want to chop down, or rangelands and grasslands. So again, it's a well-known fact of the concern of air contamination from mining. And again, if you look at what they found in Australia, problems with respiratory disease and hazardous dust continues to impact people and communities across Australia. So that's a little warning sign there. And that is, in today's world, be careful. And there are multiple things that they do in mining, just from grinding, from the slag, from beneficiation or smelting, to the tailings. And again, tailings are permanent, not 100 years. And under the LD 820, you have to file for 100 years. What are you going to do after that? But tailings are going to be there because these are reactive and toxic chemicals. And here's some, you can breathe it in. And a lot of, talk has been about water contamination, but air contamination, the small fine particulate particles, very small, 1/30th the size of a hair, that are generated by beneficiation and some of the processes they have, can get into your lungs. And then once they're in your lungs, it's possible they can get into your blood and distribute it, or they can directly go, you can breathe in, directly go not only through your blood, but up just through the olfactory nerve and into your brain. And that's been demonstrated on autopsy on humans, and also it's been demonstrated in mice. Although mice models are not humans, it certainly gives you an idea. So this is concerning. This is very concerning. And again, when you look at the lungs, the smaller the particles, the farther they get. Large particles are caught in your nasal, in your nose by your hairs and your mucus. If you swallow that stuff, though, it's going to go in your GI tract and maybe absorb. But otherwise, these small particles just are absorbed in your lungs. Very similar when you take an inhaler for asthma. Those small particles, go right into your lungs and into your blood. So this is something that is very concerning. That again, these sort of health factors aren't given much concern and much lip, which is a real shame. I mean, look at there are a whole bunch of bad things. And again, iron, say, for example, iron is very good. Too little iron, you get iron deficiency anemia. You get high iron acutely, you get iron poisoning, which is a real disaster in children when they take a bottle of iron tonic. Or you can get chronic hemosiderosis. But when you look at the baddies, arsenic, mercury, lead, which I'll talk to more, cadmium and chromium. And of course, and there are other things out there like PFASs. Now, the state sure is paying a lot of attention to PFASs as they are. I don't think they're paying much attention to metal exposure from mining, and also PCBs. Now, what are PCBs doing in mining? I don't know, but they found it at the Callaghan site. So you better watch out for everything. And again, looking at lead, there are lead levels, and they keep back in the 70s. They said, 40 level of 40 micrograms per deciliter of lead is okay. But as we learn more and more and more in the last 50 years, they've reduced it. And now it's down to 3.5. Now, this isn't a safe level, but this is a level that administrators use to say, okay, we're going to do something right here. Again, it's not a safe level because the CDC that says, yes, the recommended blood level the blood lead level is 3.5 micrograms per deciliter, they turn around and say, but there is absolutely no safe level of lead exposure for children. And this is not only by the US CDC, it's also, you look through the medical literature. It can go from things like hearing loss or lead, very commonly in pediatrics. You go ahead, a patient will come in with anemia and it's not iron deficiency or maybe iron deficiency, but it's also lead poisoning on top of that. It's very mild. You can have just some hearing problems. You can get lower IQ, which is when you start losing IQ points, it has profound sociological and economic implications, decreased ability to school and underperformance in school. And then you can have hearing and defects, slow development, either in utero as a fetus when you're a small child. And again, occasionally, although it's not really through inhalation, in the summer months in southern cities that I've seen children come in with coma and swelling of the brain from lead exposure. And the cost of one IQ point, one IQ point. Now, what difference does that make unless it's your kid? But typically, it's going to be more than one IQ point. When somebody comes into a psychologist or pediatrician's office for a developmental evaluation, typically they don't find, although we have very sensitive tests now as opposed to when I was in training, but you can pick up small changes in IQ points, and one IQ point is worth $22,589. And that's just for one IQ point. And most of the time you get 5 or 6 IQ points, but that's only for loss in lifetime earnings. And again, that's an average. For what it's worth, it's an average, but it doesn't include the really expensive stuff associated medical, psychological, educational, or criminal justice costs. And it doesn't include, you tax those earnings, so it's not including the loss of revenue in the municipalities. And let me tell you, when we're talking about having been a selectman in the town of Sweden, the two big costs were winter roads and the contribution of the taxpayers to the local school district. And of that, the big cost was special ed and healthcare. And that's where all these toxic metals come in, because that's a big cost to the taxpayers, is special ed. That can, arsenic, lead, mercury especially, can cause neurological and psychological problems. And then when you start, if you're 1.2 miles from a active old lead mine that's reactivated, now they're going for the gold and silver, but there's still a lot of lead around there. Although lead certainly has economic value. I was shocked to hear that, I guess, for batteries, but that could affect your teachers, especially if they're pregnant, and their family and the whole community. So it's 2,589 is a small amount. You probably double or triple that loss of one IQ point. Now I've talked about air, but water quality, I've talked about that. But remember, with water quality, if you look, and I just looked this up recently, Code for Federal Register, Title 40, Chapter 1, Subchapter N, Part 440, but they can put out a lot. They're talking about here as far as what effluent can come out of the mining area, and you can put out a fair amount of lead, mercury, zinc, cadmium that can come out, and that's legal. That is legal, and that's why you have to have dams around your dry tailings. But remember, a little rain, they're not going to be very dry anymore, and it come out of your dry tailings. And they say, oh well, we put down composite membranes and clay. Well, as was pointed out by Representative Ziegler earlier, or I guess about a year ago in the State Environment and Natural Resources Committee, that those membranes, he gave an example of Callaghan, those membranes can leak, and there are other reasons why it can leak. And if you have a tailings pile 60 feet high, which is not uncommon in the United States, you're going to have, even though it's covered, you're going to have wind blowing it, and you're going to put a lot of all those metals and small particulates flying all around. So again, you can have effluents you can have a fair amount coming out. You wouldn't want to drink that water coming out of there, and it's perfectly legal. And you can, and if they're not measuring it, and that's going to be a real problem in the state of Maine, if they're not measuring what's coming out and being on top of it, it can be a lot higher because nobody will ever know. And again, water, that's a hot topic, at least in Australia, and again, water, and this is from the Mining Technology magazine, water, a known polluter and guzzler, and that is a real problem today. And if you look at the Chapter 200 rules, which are based on LDA 20, why am I having such heartburn about water is because if you look on the right side here, water quality, page 65, you can have contamination of the groundwater that may occur within the mining area. That is the law. You can't have contamination of the groundwater past the mining area. You can contaminate the mining area. Now, if you have 200, 300, 500 acres of the mining area, how you can obtain that water? Arsenic, lead, and mercury are going to be underground and read the signs not to cross. You're going to have test wells, and you're going to have very, very tight and strict protocols to prevent it. And I doubt if that's going to occur, because you got to look, as has been pointed out, at even the new advanced mines, what's happening today. And again, as we talked about, acid mine drainage, and that's a problem because it does take mining activity to start it, but once it's going, just like the old Roman mines, the no more mining activity, it keeps on going and going and going. And the top picture there is Gold King mine, I think, on the Amanus River, where the guy sampling the water is in a hazmat suit with the mask. I hope he got to shore in his dinghy that didn't get eroded by all the acid. So anyway, acid mine drainage, it will go ahead and once it gets going, it'll go down into the ground, and in the areas where they really haven't mined yet, start eroding and taking more of those metals, toxic metals, and distributing it. And I don't, again, don't need to go into that, but not only are there problems with acid mine with water consumption, but there's sediment, temperature, and they use cyanide. Under the law, they can use cyanide and mercury to precipitate out gold. And again, about 30% of all the cyanide used in toxic release inventory comes from mining, and it affects everything else. Decreased oxygen consumption, which ain't good for people who drink the water, and it ain't good certainly for all the shellfish. They can have dioxins and explosive perchlorate. You need to find out if they're using, because I think they're already using explosive. Are they using perchlorate? At least the U.S. Department of Defense has really been on top of this. Perchlorate is profoundly soluble. It's a very, very water soluble compound, probably more soluble than just sodium chloride or salt. And if you get that into a pregnant mother affecting the fetus, a small child, it can affect the thyroid. And although a lot of adults have hypothyroid, they take pills, they seem to be doing okay. But when you have a developing fetus that's problems with this thyroid balance, you can have profound neurologic and developmental problems. And now let's talk about how you need to measure. They're going to be generating, as we saw in that one chart from Arizona University, a tremendous amount of particulate matter. So there are two things you really have to look at. And the state of Maine knows this. They didn't really mention, I'll get to it later in the mining law, but if they're going to have stacks such as beneficiation, where they take the stuff they dig up and they start adding heat to it, calcining, briquetting, and also you could say on the definition they have in LD 820, smelting, they add a tremendous amount of heat up to 2,000 degrees Fahrenheit, 2,000 degrees Fahrenheit, and goes up a stack. Now they say they have filters, but a lot's going to come out. So you need to make sure that they have continuous monitoring of the stacks. But then there's something called fugitive emissions, and those are emissions, everything that comes out of stacks by definition. And again, you can use X-ray fluorescence or XRF for fence line, because you want to know what's leaving the community. And you can do that by fence line. You have to look at soil levels. And although it's not really a monitoring equipment, what you need to do ahead of time is their exposure models, where they take, this is what's happening, this is what's being put out, if they know, and they're not going to know about mining because there's no history of mining in Maine. Again, they have Western mining, which is entirely different, even though they took the law from the West, copy and paste, and made it LD 820. But you want to do the human exposure model, which is a model, and you estimate what's happening. But you want to know what's coming out of the stacks when they do beneficiation and smelting, which they can do right in Pembroke, anywhere they're doing it. They say we might send it elsewhere. They might do the final smelting elsewhere, but still with calcining and roasting, they add acid or other chemical, cyanide, and they heat it up, and it's going to come out of stack. And they're not going to get all the nasty stuff coming out of the stack. Some's going to go in the air. And then there's what they, again, fugitive, where just sort of a truck dumps some stuff and all that dust goes up. And you need to get both of these. That's not specified in LD 820. So you need to make sure in your local ordinances that you do that to protect yourselves, your children, and your industry. And then water contamination is a big deal. Well, what are some things you need to do? You have to have test wells. You have to test wells around where they have excavation, where they have the beneficiation and storage. You know, not only the tailings, now how I remember tailings, T for toxic, and that's tailings, and then the overburden. And you need to have independent third-party people doing this. And this is expensive, so the mining people aren't going to want to do it because it cuts in their profit margin, even though they're right in the middle of your community, by your schools, by your homes, by your shellfish. And then you also have community testing far away. Have to test, trust, but as Ronald Reagan said, trust but verify, and you better verify. And the other things you can see, that you can see with mining is you can have noise, lights, blasting, road traffic. In Pembroke, they were talking about one heavy 5-ton truck every hour, every day for the whole year. You have obnoxious odors. Like I say, beneficiation and smelting make particulate matter. They heat it up and it goes far. You have to do your water quality and availability. And then other things that'll happen, especially if you're only a couple of miles away from it, is stress. And as you've seen, there can be, just in general, the noise, 24/7, the lights, everything, that's going on. Then you can have catastrophic and unanticipated events, like your dams that they need around even the dry tailings. If they get wet after a heavy rain or climate change event, you're having problems. And then as a former selectman in town of Sweden, it'd be real stressful as property values go down and tax values go down, and just stress in general, knowing all this is going on, the noise, the lights, and everything where you can't sleep. Now, somebody's going to say, well, look, we're going to assess the risk, and we're going to look at all the combined risks and say, we're going to look at that. We know that, arsenic level is only 3/4 of an action level, and the lead level is only 3/4 of an action level. So it really doesn't count. And so, they try to add them together. So 1 and 1 is 2, but that ain't the real world. Very frequently, you take one toxin that has an effect, say, of 1, another toxin has an effect of 1. You can't say it's 2, it could be 5 or 6. And let me give you a very crude example is some of you may be taking statins for cholesterol, things like that. And you drink grapefruit juice is great. I mean, you can get toxicity from it if you take a lot and you're diabetic, or if you take a tremendous amount, get fluid overload, but it really has minor toxicity. Statins by themselves have minor toxicity, but if you add statins in grapefruit juice, you can get liver damage. So it's not 1 and 1 equals 2, it's 1 and 1 equals 5. And the same sort of things, you get a little bit of arsenic, get a little bit of mercury together in a patient, or even zinc, and you say, oh, that's not much. But when they get together, the effect is greater than adding just each effect individually added together. And that's in the real world. And the mining industry may not know about it. I'm sure they do. They just don't care to know about it. Let me tell you again, the medicine knows about it, that when metals can act as co-carcinogens in combination with themselves or with non-metal carcinogens, and you can DNA changes, altered cell signaling. So the cells say keep on reproducing, you get a big tumor, you can get changes with your inheritance. So again, this is a big deal, and it doesn't take a whole lot, and it's very hard to predict. It is very hard to predict. You can predict it after the fact, and you can do sometimes before the fact, some are known, but when you look at all the different metals, all the different concentrations where you can breathe them in, come in through your GI tract or through dermal absorption, it's very hard, but that is a real world, and that is my concern. And again, there are all sorts, you got to be very careful and say, oh, this is within normal limits. This is, if you want to look on the side, that's concentration. And this is sort of danger sign. So when you look on the column on the right, where it says NIOSH, National Institute of Occupational Safety and Health, well, that's for, there they can tolerate, say, I think this was for arsenic, they can tolerate a higher level. That's because they're a healthy adult who's wearing protective clothing for only 40 hours a day. Whereas if you want to look at small children with cancer, they're way down at the bottom. So again, you got to be careful and say, oh, that's within normal limits. What limits are you talking about? You're talking about the healthy male industrial site who's wearing protective clothing, or you're talking about a child or pregnant mother who's exposed to it 24/7 or nearly like that where they live. So again, you got to be careful what limits they're talking about and how they calculate what goes into those limits. And what really gives me concern is that they say, oh, well, even the strictest limit, you're okay, but there's something called, the period of greatest development. And that's where like the heart is being formed, the nervous system is forming, or the palate, things like that, genitalia or ear, that a minuscule amount or a minuscule stress can cause a major defect. And that's why I come to what's called the precautionary principle. If where there isn't good, strong science that shows it's safe, you better be very careful and very cautious. And I think that's a good, and mining is a good example of it. When I was a medical student, at William Beaumont Army Hospital many, many years ago, they had smelting, which is from a zinc and lead smelter on the border of the United States and Mexico in El Paso. And I didn't take this picture, but it's taken about the same time that I was there. You can see the tall tower that they had. And of course, just put everything up in the air, quote, get away with it. And there is a cemetery from the colonias of the local people, Mexican-American people, in large part, most of those people worked at the smelter. And I think that's why you have to be very, very cautious. I did a very small, this is when they first established what they considered a safe level of lead at 40 micrograms per deciliter of blood, and now it's down to 3.5 administratively. But as we know, there is no safe level of lead. And then when you start adding arsenic, lead, cadmium, you're adding increased risk of cancer, and you're adding increased risk of developmental problems. So again, I think you need to be very, very careful. And again, they say in our strictest, greenest law, you can't have, they'll tell you, you can't have open pit. Well, you can, if you look at it very carefully, you can have 3 acres of open pit. And if you look at there, you can see the main state house on one end and the cross office building on the other. Actually, this is 3.3 acres. But you can see the size of it. So again, you can have a fairly large open pit legally and still generate a fair amount of particulate matter. And again, I think with LD 820, chapter 200 rules, that human health effects were given lip service, but they were basically ignored. And I think it's very important as you are looking at protecting your shellfish that you're going to eat and your economic strength, and you're looking at protecting your health, especially that of your children. It's better to prevent it than to treat it. Because if you look at the LD 820, it says, yes, they can intervene after the standards are violated. Well, how are they going to know if they're violated? They have to test. They have to have monitoring, and look in the law, it mentions, doesn't specify how they're going to have monitoring. I don't think one poor guy in Augusta is going to be able to monitor all these different mining sites. So again, that's going to be up to local effect. And again, here are some of the problems that I see with mining. And under the mining law, there's no mandated coverage for screening or treatment of pollution-related health issues. And where are they going to get money? They say, we'll have a mining, excise fund. Well, I don't know anything about taxation, but if you go ahead and look at, I believe it is Title 36, Chapter 371, Section 285 or 281, 258, 2851, the tax law, the taxes that can become taken from mining can be as low as 0.9%. If you look at other states, Nevada, Utah, Arizona, it varies, and really doing apples and oranges, but it can be up to 6 to 8%. So there isn't going to be a whole lot of money there to remediate, or there's going to be a whole lot of money to take care of these, to take care of any problems that they come. And again, if you look in the law, what is perfectly legal in the current law, they can excavate 300 feet from a school or public property. They can have waste units, tailings, or beneficiation, where they're taking, like the Asarco smelter in El Paso, and it can be only 1,000 feet away. And that is a law. Although there are 41,111 words in I did word count, and that include the index on the chapter 200 rules, they're less than 300 for air monitoring or air quality, and less than 300 for water quality, and just say that the standards cannot be broken. They don't say about monitoring. So if you don't monitor, they don't demand adequate monitoring, which would be continuous monitoring of the stacks and continuous fence line monitoring. You'll never know. And they'll say, we didn't cause any problems because we don't have any data. Why don't we have any data? Well, we followed the law. And also, in the law, they didn't demand, there's something called pollution exclusion in a lot of your, in almost all your insurance policies, because insurance companies aren't dumb. They don't want to, insure something they're going to have to pay out on. So there's a pollution exclusion clause, and that's standard in a lot of these insurance policies. You better make sure if somebody has like a liability insurance policy, say, oh, we're covered with liability, might cover the workers, make sure it covers pollution outside of it. And again, what really gets me is that but they do have an imminent danger clause in the law. But they say you can take action with imminent danger, but there has to be a violation. And if there is a violation of lead, if they're letting lead out, you're going to have to measure it, and then you're going to have to analyze. Then you're going to have to go to court and have a hearing before you have a violation. You need to have something where beforehand that it never comes out, but if it does, you can take imminent action before you have to go through all the legal rigmarole. Because the best thing for the lawyers, they can have something in the court for 5 years, and then there'll be some sort of settlement. And again, rehab, better be very careful about rehab, because in the Minneapolis Star Tribune, they talked about one of the mines, and they said they put away $23 million to remediate. Well, and as we point out in that article, $23 million would only cover an assessment. What it would, get all the engineers to figure out what they're going to do. It wouldn't cover remediation. And if you look at the market cap of Wolfton, I think on Friday, it was $26.8 million total market cap on the, you can look it up, WLF. And it was only $26.8 million. That ain't going to cover remediation. And they're talking about having all these mines everywhere else. Just one mine's going to break the bank. And here you go. This is just recent. 3 or 4 times the initial estimate of remediation of just recently in the end of November in a mine in Stafford, Vermont. So again, what the estimation for remediation, what it really comes out as, and who's going to foot the bill, because a superfund, U.S. superfund, is just about bankrupt. And right now, luckily, we're only paying 10% for the Callaghan Mine. It's going to go on forever, but something else, they're either going to abandon it, leave it as a festering sore, or somebody's going to have to pay for it, because there won't be enough money put up by the miners for remediation. And again, I think the miners, what they want to do is get out quick and leave the mess behind. And that's what concerns me. What can be done? My understanding is that the state representative from Pembroke is a nurse, and I sure would talk to her, because I think if she knew about this, she'd be, concerned. The other thing I like to say, I've tried to talk to them, but when you see the Wolfton health and safety officers walking around Pembroke, tell them I'd love to discuss with them the health effects of the toxic metals they're about to dig up, because I think that's a very important point. And I'd love to discuss on a Zoom conference or whatever with them about it, because I'm just afraid that, as they've done everywhere else, they're going to take the money and run, just like this Harrier pilot did in the Kandahar airport. He got the heck out of there real quick before his plane exploded on his, and he survived actually on his Martin Baker ejection seat. So anyway, again, I'd like to thank you very much for your time. And like I say, I use metals a lot in my profession and in my personal life. They're very important, but it has to be done right. And when you look at the effects of mining, not only metals, but water contamination, like I say, petrochemical sewage, PCBs, there are a lot of problems there, and they have to be watched and monitored very quickly ahead of time, because once lead or arsenic or mercury gets into somebody's body, you got problems. You ain't going to get it out there. Chelating agents, but they don't work as well. They don't work very well at all. I can tell you firsthand information. So I think you really need to be ahead of the curve on this. Mining is vital, but you have to really be ahead of the curve. So thank you very much for listening to me.
Oh, thank you so much, Bruce, for joining us during your holiday. So now we've come to the end of our 3 very generous speakers, and we're coming to the question and answer portion of our show. We thank those of you who've got such stamina for sticking with us. This recording will be available on the website. So if you know people who, were out enjoying the beautiful snow, maybe you can urge them to use another one of their evenings to catch up on this mining issue. If anyone's ready with a question, you can go ahead. Otherwise, I'm happy to give some more follow-up. Okay, hearing none. Oh wait, iPad, admit. Hearing no questions, let me introduce Michelle Henkin from the Pine Tree Amendment to talk about how her proposed amendment that's waiting for enough support to get into the to get voted on in the legislature might address the questions and concerns that we have about clean water in Maine.
Hi, everybody. I wanted to just say what an amazing presentation this was, and thank you, Severin, for all the work that you're doing to get this information out and to rally people. These issues are incredibly concerning, and the kind of evidence that came forward in this webinar is the kind of deep analysis that's going to be required and should be required of government and its agencies as they examine and make decisions. Unfortunately, they're not doing that. They're not obligated to do that, really. So my fellow co-coordinator, Andy Burt's on this call as well. We've been working on the Pine Tree Amendment, which is LD 489, which would establish the right to a clean and healthy environment for all people in Maine, including future generations. And it's going through the legislature right now, and we're seeking grassroots support to help us make our case to legislators, because what it would do would hold government constitutionally obligated to not infringe upon our right to clean air and clean water. And it would, someone spoke earlier, I think it was the doctor who spoke about needing something to be violated before we can take action. I believe that you don't need permits to do test drilling. If a Pine Tree Amendment was part of the Constitution, then we as citizens, community members could say, prove to us that this won't do harm before you do anything, before anything is allowed to happen. We don't have standing at this point. And so we are in the final stages of trying to get this amendment through the legislature, where we'll need 2/3 support from each chamber. We're working particularly hard on getting House members to support. And so we have a series of letters that we've drafted that can be found on our website. We've also put the website in the chat, as well as our recent newsletter, which also has links to all these letters. And they are putting a face on the people that support the amendment. And we encourage you to go to our website, check it out, and sign as many letters as you feel you identify with, pass them around to your friends, because this is our chance to get the kind of protection that we need to address problems before they, are allowed to go forward. Watching this unfold at the Pembroke site is heart-wrenching, and same with the PFAS situation. And there's so many issues in Maine that need addressing, and this kind of constitutional protection would go a long way towards giving us a really powerful tool. So,
and just echoing what Ralph Chapman said in our last training, that the legislators really don't have scientific support. They don't have a bunch of researchers there helping them parse the presentation of industry. And so often they rely on nonprofits and on industry representatives and lobbyists to inform and guide them. So if there was a constitutional requirement for them to be informed what the impacts would be on air and water, that could also help us make sure that there's a science to back up the claims that are made. Now, I don't want to interrupt anyone else's questions, but I've noticed nobody said anything. Lise, you're talking, but you're muted. Oh, are you asking a question, Lise? No, she's not. So let me then proceed to talk about the next event, which is on February 20th, again on Sunday at 3 o'clock. We're really honored to have Winona LaDuke, who's been an amazing organizer against pipelines, especially, and protecting water. And John Banks, who's been an environmental, not agent, but running the environmental office of the Penobscot Nation. Penobscot River, as you know, has been a dumping site for many industries, and the contamination that has resulted, is testable, you know, we as part of our kelp farm where we had our kelp tested, our farmed kelp tested, and there's been research testing kelps from around the state of Maine. And, you know, the kelp out on North Haven has got a lot more heavy metals on it, even though you think, well, it's so far out in the bay, why would it be so contaminated? Well, it's because of the Penobscot River coming down. So I think, especially as we see so much promotion of working waterfront and kelp can help and win-win and coastal livelihoods, and all of us young people who are passionate moving to this state to start small businesses in organic agriculture and aquaculture and oysters and kelp, and wanting to participate in, you know, propping up, you know, getting into on select boards and putting kids in schools and being a part of rural Maine. Well, if the water's poison, we can't do any of that. So please spread the word about Winona LaDuke and John Banks speaking on February 20th. Then we're working on another event that looks especially at the Medibemps contamination and a training about monitoring and testing. That's going to be run by Stacy Kalk. I want to urge everyone to follow along as well with the Friends of Cobscook Bay, our allies in clean water. And to say, if you know someone who's passionate about this subject and who's looking to get involved, we are definitely looking for more people to be involved. And, you know, just come along and get in touch with us at cleanwater@greenhorns.org. We're so grateful for the support of the Sewell Foundation, Sakaruna Foundation, and others who have helped us with legal fees, with the work on the ordinance, and coordinating all this information. So thank you all for your attendance and your continuing patience with this big project of stopping the mine.
And Severin, thank you so much for organizing this, for staying with it, and to all the speakers who were incredibly informative. And we're very grateful. Thank you.
And thank you to you, Lise. Thank you to